Welcome viewers, in this video we will see the implementation of the Boolean function using NOR logic. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the problem. We need to implement the following Boolean function using NOR logic. The given Boolean function is y equal to AC plus BC plus AB plus D. Right, there are four variables available A, B, C, D. In order to implement with the NOR logic, we will take the complement on both sides, so that we will get the plus symbol. So A into C mean AND operation, B into C mean AND operation, A plus B mean we can go OR operation. So in order to get the OR operation, the complement is taken on both the side. Y bar equal to AC plus BC plus AB plus D the whole bar. How will you write this? Based on the De Morgan's theorem, A plus B the whole bar equal to A bar dot B bar, right? The plus become multiplication, right? So based on that, A, B, C, D the whole bar is nothing but A bar dot B bar dot C bar dot D bar. Based on that, AC bar into BC bar into AB bar into D bar. Again, this value, this AC bar can be written as, based on the De Morgan's theorem, AB whole bar equal to A bar plus B bar. Based on the second De Morgan's theorem, we can write. So that AC bar is written as A bar plus C bar dot. BC bar is written as B bar plus C bar. AB bar is written as A bar plus B bar into D bar. Right? Now we got the expression in terms of addition. Now we got A bar plus C bar one term, B bar plus C bar another term, A bar plus B bar another term, third term, and then fourth one is D bar. Now we can implement this with the NOR logic, because here the plus symbol is available. Now we'll see that there are four functions are there: A bar plus C bar, B bar plus C bar, A bar plus B bar, and D bar. Now we'll go to the logic function. First we will implement with the normal OR gate and AND gate. Then we will go to the NOR logic. We will go with the normal function. So for implementing A bar plus C bar, we need one OR gate. B bar plus C bar, another OR gate. A bar plus B bar, another OR gate. Then D bar is given. Right? So we are using 3 OR gate to perform this function. Right? So in the first OR gate, the A bar and C bar is given as a input. What is the output for this? OR gate means addition. So it will give A bar plus C bar. Second OR gate, the input is given as B bar and C bar. So the output of this OR gate is nothing but B bar plus C bar. Right. In the third OR gate, the input is given as A bar plus B bar. The output will be A bar plus B bar. So these three inputs are given to one more AND gate in order to get the multiplication. So one more D also given, D bar. The fourth term is available as D bar, right? So the D bar also given. So these four terms will be multiplied, right? So the output of this AND gate is nothing but multiplication of four terms. Y bar equal to A bar plus C bar into B bar plus C bar into A bar plus B bar into D bar, right? So now the given Boolean function is implemented with normal OR gate and AND gate. So we got the desired output. Now we'll same thing we will implement with only NOR logic. That is the question. The question is we need to implement with only the NOR logic. So this is the implementation with AND and OR logic. Now we'll go to the NOR logic. So now we'll implement with NOR logic, NOR logic, right? First one NOR gate is available. Input is A bar and C bar. The output of this NOR gate is nothing but A bar plus C bar the whole bar. Normal OR gate means A bar plus B bar. NOR gate means we will get complement A bar plus C bar the whole bar. In the second NOR gate we given input B bar and C bar. So we will get the output as B bar plus C bar the whole bar. Right. The third NOR gate we given output as A bar and B bar. So the output will be A bar plus B bar the whole bar. Right. So these three are the required outputs. Right. The fourth one is the D bar. Only D bar. Right. Only one input is available. So we need to get the inverted output. We are using this NOR gate with the two inputs are common. two inputs are short circuited, commonly given. If the NOR gate with two inputs are short circuited and common input is given, it will act as a NOT gate, right? So the D bar is given, we'll get D double bar. So everywhere double bar is available, so we'll make it as D bar into D double bar, right? Now we got the four outputs: A bar plus C bar the whole bar, B bar plus C bar the whole bar, A bar plus B bar the whole bar, and D double bar. That is given to another NOR gate. So this NOR gate, what it will do, it will add all this value and make a complement, right? A bar plus C bar whole bar, everything will be added, and one more complement will be available, so that it is Y bar. But our desired output is Y is needed. So again we are connected with one more NOR gate with the common input. Common input means it will act as a NOT gate. So Y bar means it will give the output as Y. So Y is our desired output, right? So the Y bar now is inverted and will give the Y. Now we'll verify the expression. This Y bar is nothing but sum of these four terms with a complement, right? So we'll verify whether we got this Y bar from Y in the expression. So that Y bar equal to, so it is given as Y bar equal to A bar plus C bar the whole bar plus B bar plus C bar the whole bar plus A bar plus B bar the whole bar plus D double bar. So this is the NOR gate. These four terms are added and and then the entire complement, because NOR gate will add all the terms and will give the complement, right? Now we can implement the De Morgan's theorem. A bar plus C bar the whole bar is nothing but A bar into B bar, right? So we can use this De Morgan's theorem. A plus B the whole bar equal to A bar dot B bar, right? So based on that, A bar plus C bar the whole bar is nothing but A bar into C bar. Already one bar is there, so we got double bar. Here already one bar is there. From De Morgan's theorem we got one more bar. So A double bar into C double bar. Similarly the same thing applied here also, right? So B double bar into C double bar. Here also A double bar into B double bar. Here D bar is as it is. Here D double bar is written as it is, right? So everywhere we have double bar so that we can remove, right? Complement of double complement will give original value. So that AC plus BC plus AB into D to the whole bar. So this is the output of Y bar, right? So by removing the complement on both the side, we will got Y, because where at the end we used one NOT gate. So by that NOT gate will remove this complement. So that Y equal to AC plus BC plus AB plus D. So this is our required output, required function of the given Boolean function, required output of the Boolean function, right? So we verified with the expression also. This is the given expression. By applying De Morgan's theorem step by step and taking the complement on both the side, we got the desired output, right? So in this video we discuss about the implementation of the Boolean function using NOR logic. The given function is first simplified and bring it into the OR function. Then it is implemented with OR gate and NOT gate, OR gate and AND gate, normal implementation. The same thing implemented with NOR logic, right? After implementation we verified the expression also. We got the desired output. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.